Torus here, torus there, donut, 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 and torus. Torus is everywhere. Even there's a math channel named the Honest Torus. But what's a torus and how can we actually describe it? A torus is a manifold. More precisely, they are called n-torus, which n represents the number of holes in your manifold. To describe an n-torus, we need to get familiar with the product spaces. What are they? Well, suppose you have logical spaces x1 all the way to xn, then it can be shown that with the Cartesian product x1, x2 all the way to xn is also a topological space with the open sets defined as the Cartesian product of u1, u2 all the way to un, which each of them represents the open sets of xi. Now, if you don't know about topology or manifold, go see my previous video which I explained them and introduced you a source to read from. To describe a torus, all you need to do is take the manifold S, which represents a circle, then S multiplied by S will be a torus. How do we know that this is a manifold? Well, this is one of the main properties of manifold. The Cartesian product of an n1 manifold with n2 manifold will be the manifold of dimension n1 plus n2, which can be shown easily. Another way to describe the torus is using the quotient topology. What's the quotient topology? Well, if you have logical spaces x and y, and Q is a surjective map from x to y, then we can define a topology on y by declaring a subset U to be open. The Q inverse of U is open in X. This is called a quotient topology, and you can indeed prove that this is a topology. We call Q here the quotient map. Here we need a bit of set theory. As we know in set theory, if we define a relation on a set, then it gives us a partition of that set. Now let's take a look at the Q from X to X quotient, which sends each of these elements to its unique equivalence set. Then X quotient together with the quotient topology induced by Q is called the quotient space of X. Now we can construct a torus. We define an equivalence relation on I Cartesian product I by setting these two relations. Believe it or not, now I Cartesian product I with this relation is the torus. But how? Well, we can visualize this as the following. Since these two lines are equivalent to each other, then we can think of them as one and glue one end of the square the other. Now, as you can see, this becomes a cylinder. Let's do the same thing for the other ends and glue them. Now, this becomes a torus. I hope you have enjoyed this video. Subscribe for more content like this. Thanks for watching.